Hello students, this video is meant to accompany your quiz review on lessons 1 through 5. Your quiz on this is on Friday, and this video and the quiz review are optional. You don't have to complete either one. They're just for your benefit if you would like to study for the quiz. Okay, so let's start with number 1. Number 1 says write the slope-intercept form of each equation, and 1a says that it's a line, of course. The line goes through 1, 3, and the slope is negative 2/3. So what I know then is y equals negative 2/3 x plus b. I don't have the y-intercept here, so what I have to do is use this ordered pair and plug in the y, the 3 for the y, and the 1 for the x, and then find b, because that'll be my only unknown at that point. So let's plug in a 3 here, and then a 1 for x. And so let's see, that would be 3 equals negative 2/3 plus b. Well, 3 is, if I convert that to a fraction that has 3 as the denominator, that's going to be 9/3. So, and then if I add the 2/3 on both sides, plus 2/3, I get 9/3 plus 2/3 equals b. So that's 11/3 equals b. So now I have all my parts that I need. I could just plug in an 11/3 right here. So just rewrite the original equation. Let's do that right here. Y equals negative 2/3 x plus 11/3. Okay, so I moved it down here so we have room over here. I'll do this in a different color so we don't get them mixed up. So this one again says slope-intercept form, so we know it's a line. We have some ordered pairs, and one thing that I notice is where x is 0, y is 6. So I know that the b part of that is going to be 6. I don't know the slope, but I can find the slope by using ordered pairs. If I'm going to use the lowest ones. So negative 3, 1 is one of them, and 0, 6 is the other one. So if I take 6 minus 1, numerator, and then 0 minus negative 3, which is 0 plus 3, that's going to give me 5/3. So that's the slope. So I have everything I need now. I have y equals 5/3 x plus 6. Okay, moving on, number 2 says use the points or graph to write a quadratic equation in the specified form. This is not on yours, and it's not supposed to be on yours. So you didn't get to choose 2 out of 3. Okay, so the first one, 2a, says write it in intercept form. We know it's a quadratic, so we know it should have no more than 2 roots. The negative 4 is one of them, and 0 is one of them. So I know that my equation is going to look something like this. And then I also have this other point here, the third point, that I can use to find a. Make the a the only unknown, plug in the 20 for the y. And you can fast forward through this if you want, but I just want to kind of illustrate this a little bit. So we're going to plug in 20 there, and then we're going to plug in negative 2 for the x's. Let's see, 20 equals a times negative 2 plus 4, negative 2 minus 0. 20 equals a times, that's 2, and that is negative 2. 2 times negative 2 is negative 4. Divide by negative 4. Negative 5 equals a. I'm not quite finished yet. I need to rewrite my original equation. Let's see. Y equals, and then fill in the negative 5 for a. Negative 5. And I can put the first x right here. X minus 0, I don't need that as a factor in parentheses. I can just put it right there. So 5x, x plus 4. I'm sorry, I said 5x. I meant negative 5x. Okay, part, they give us the vertex and they give us another point. Y, trying to get red. Y equals, we still have to find an A, x plus 6 minus, excuse me, that's supposed to be squared, minus 100. I need to find the A by plugging in 44 for Y and 0 for X. Okay, so I have kind of a two-step equation here. I need to add 100 over here. Just turn that around, divide by 36. A equals 4. Rewrite the original equation. That's the answer. Okay, and the last one in this section, 2C, write the standard form. So we can start out by writing intercept form and then multiply it out to get standard form. So what do I need for intercept form? I need the intercepts. I need the x-intercepts or zeros. This one is 1, and then this one is -3. I'm going to need another point. This one is 0, -2. Yeah, I don't need this point. This one's like between two lines, and I don't want to try to estimate what that is. That would be too hard to do. So my intercepts are right as factors. Remember, you're going to take the opposite of these numbers to put them in the parentheses. I need to find A, so I'm going to use this point right here to find A. -2 plugs in for Y, and 0 for X. Let's see, that's 3 times -1, -3. Divide by -3, A equals 2/3. I think, is that all I need? Oh, okay, that's right. They said write it in standard form. That's why. Okay, so A equals 2/3. I'm gonna erase. I just need a little more room. So I can rewrite Y equals 2/3 x plus 3, x minus 1. They wanted standard form. I'm probably not going to ask you for standard form, but when you do standard form, you got to multiply all this out. So Y equals 2/3, that's going to be x squared plus 2x minus 3. And then you would just multiply that 2/3 in there. So to do that, I'm going to do this. Y equals 2/3 x squared. That's going to be I get plus 4/3. My key says 8/3, but unless I did something wrong, I don't think I did. -3, times 2/3. That's 3/1. The 3's cancel, and so that's -2. So that's what I get. If you get something different when you work this out, let me know. Because my key says something different. It has 8/3 right here, but I'm pretty sure 2 times 2 is 4, and 3 times 1 is 3. So, okay. Next section, number 3, says convert to intercept form. I need to take a -1 out of this because I can't factor this with that being a negative. So let's take a -1 out. 36, my two numbers are 9 and 4. 9 needs to be negative. This one, I'm going to multiply everything out first and then do intercept form. Remember that x minus 1 quantity squared is x minus 1 times x minus 1. So let's see, I get, that's negative 1 times negative 1, which is positive 1, minus 4 is minus 3. Okay. And then I look at the negative 3, factor pair for negative 3, that when I add them I get negative 2. That's going to be minus 3 plus 1. Okay, and then the last one in this section, I need to take out a 5. All of these have a factor of 5, so I need to take out the 5. Remember, I don't really want you to don't get rid of the 5. You're just taking out a 5. You're not dividing everything by 5. You're not like putting a 5 under here, because that's not the same thing as taking out a greatest common factor. So don't do that and then you can get rid of it, because if you divide by 5 on this side, you got to divide by 5 on this side, and you want this to stay y. So I'm taking out a greatest common factor. I am dividing everything by 5 when I do that, but I'm not dividing both sides by 5 here. So this is going to be, let's see, x squared minus 6x, excuse me, sorry, minus 16. Now, can I factor this? Factor pair for negative 16, that when I subtract the numbers or add them together, I get negative 6. That's going to be minus 8 and plus 2. So we haven't had one where we had an a value that was greater than 1 yet. So we haven't had to do any of that grouping or splitting the middle term or anything like that. All right, so number 4 says convert each function to vertex form. Okay, so if you remember when we were doing these, I told you that I can show you how to do these without graphing. If you want to use Desmos, though, I have graphed them over here. So the first one is this red one. Just need to graph it, find the vertex, -5 and 81, and then just plug that into vertex form. So that would be plus 5, because the vertex was at -5, so that's the opposite, 12, and then minus 81. So that would be the answer. If you're interested in seeing this without graphing it, I could show you, but I'm not going to take up time on this video to do that. The next one I graphed also. Let's make this one invisible, make this one visible, and if I can find it, there it is. So let's click on the vertex. The vertex is -2 and -16. Again, there's no a value, or the a value is 1. So as long as the a value is 1, I don't need anything but, I don't need anything before the parentheses. Y equals, it was -2, so that's x plus 2. Don't forget about your exponent. And then minus 16. I also graphed this one exactly the way it is. We know it's going to be h of x equals, and then it's going to have that 4. So we need to make sure we don't forget about the 4. Let's go over here and see what the vertex was. It's way down here. So it's 1 and -100. X, that was plus 1, so we're going to put -1, -100. All right, so that's all there is to those. So instead of going back and forth to Desmos, I graphed these, and I just took a snippet of each one so we can look at them on the same page. So this is 5A, and we can look at the graph and the equation to find these key features. So x-intercepts, first of all, let's see, negative 5, 0, and 3, 0. Again, if you just write negative 5 and 3, I won't count it wrong. So I'm going to write the actual ordered pairs, though. The vertex is at negative 1, negative 8. The axis of symmetry is right here. This is counting by 2s. Okay, so yeah, so that's 2, 4, 5. So this is at x equals negative 1. The y-intercept is at 0, negative 7.5. It opens up. The maximum or minimum, it has a minimum down here, and the minimum is at negative 8. The domain goes forever left and right. So when we do domain, I want you to go left to right. From the left, it is coming from negative infinity. And to the right is going to positive infinity. Range, start at the bottom and go to the top. For the range, it starts at negative 8. It's always going to be the y values. So negative 8, and I put parentheses by mistake. This should be that bracket thing. Okay, and then it goes to positive infinity. Number 5b, here's the graph for it. X-intercepts, it doesn't show any. So what we would say is this. We would say either not real. If there are any, they are not what we call real roots. They could be imaginary. So we're just going to state that here. So you'll write that. The vertex is at negative 2, negative 1. The axis of symmetry is at x equals negative 2. Y-intercept is at 0, negative 9. It opens down, which means it has a maximum. And if you need to know what the maximum is, it's that y value, so it's at negative 1. Domain, left and right, it goes forever, so it's negative infinity to positive infinity. In the range, it comes from negative infinity, so that's the first thing we write. We don't want to get those backwards. We want to go from the bottom to the top. And it stops at negative 1. And that's a bracket. So the next section is on inverse functions, and if I go over here to my Desmos, I've opened up my inverse function kind of tool here where I can put in the function here and then it'll show me the inverse function. And then what I want to do down here is put in what I get for the inverse function and see if it matches up with the inverse function here. So my function is negative 3/5 x minus 12. So the function's in red, the inverse function is in purple. So now I'm going to go over here and find it. That was not right. Find it algebraically and see if I get that same function. Okay, if you remember, the steps to finding the inverse of a function are to, it's already written y equals, so we're going to switch the x and y. And then solve for y. So we need to get the y by itself. First thing I'm going to do is add 12 to both sides. That gives me x plus 12 on the left side equals negative 3/5 y. So I got rid of that. Now I need to get rid of this. To get rid of that, I need to, multiply times negative 5/3. So I'm going to multiply by negative 5/3 on this side, which means distributing that into this parentheses, and then that will give me y. So negative 5/3 times x is just negative 5/3 x. And when I multiply this times 12, I can simplify the 3 and the 12. So then I have minus 20. So I went over to Desmos and I typed in the original function, and then I typed in what I got for the inverse, and you see it fits right over what the inverse would be. The original function is red, the inverse is purple, and what I got is black. So that's how you can check your answer and make sure you're right. Since these are both linear, neither one of them is horizontal, the domain and range for both of them is all real numbers or negative infinity to positive infinity. The next problem is a square root function. So I switch the x and y. You need to subtract 8 and then square both sides. So this one's kind of interesting because when you graph the original function and then you look at the inverse of the original function, they are mirror images of each other. But when you find the function algebraically, you don't have a square root function anymore, you have a quadratic. So that's going to create a parabola. So half of it is actually, I guess, the inverse function graph, but we can't really find the true inverse of this because it would have to be another square root function, and we have to undo that square root. So this is correct right here. This is the correct equation, but when you graph it, it's only half of it. It's only part of it. So, domain for the first one starts at 5 and goes forever towards positive infinity. Sorry, my brain is done this afternoon. Okay, so it starts at 5, 5's included, positive infinity. And then the range starts at y equals 8 and goes toward positive infinity. And I don't even have to look at it, we already know that the domain and range just switch. So domain is 8 to positive infinity, and range is 5 to positive infinity. Okay, another square root function. I've switched the x and the y. Let's divide by 9 on both sides. I'm sorry, cube root function. I said square root. Okay, now we need to cube both sides. I can just leave that like that. And then subtract 2. So I typed in the original function on Desmos and made the inverse visible, and then I typed in the new one. Let me see. I'm trying to move this over so I can see these colors. Okay, there they are. So the black and the purple are the same function, so that's correct. The domain and range on both of these is all real numbers. So I'm not going to include this one on your quiz review. If you want me to show you how to do it, I can, but I won't give you one that looks like this anyway. The inverse of this is not a function and it does not exist, so you can mark this one out Okay, number 7, A, B, and C says state whether the following are functions or not and state the domain and range. The first one is a function because the x's don't repeat, so I don't have more than one value for any of the x's. So the answer is yes, it's a function. The domain is just the list of x values. And then the range is the list of y values. I should have put those in order probably. But the 3 repeats, you don't have to list it more than once. Just list. So B, you have more than one point in this vertical line right here, so it is not a function. It does not pass the vertical line test. The domain, again, it's all the x values. -3, 0, and 3. And then the range is -5, 0, 2, and 3. Okay, and then the last one, this is also not a function because it does not pass the vertical line test. I was looking at my key and it's wrong. This thing has arrows that go to the right and to the left. If it had just points down here, the domain would be different, but the domain's all real numbers. And so is the range. So number 8 we're almost done. Number 8 says state the parent function and transformation of each equation, then graph. So the parent function of a quadratic is y equals x squared. Transformation of this one, the negative tells me that it reflected over the x-axis. Now, this is different from square root. If it's a square root function and the negative is on the outside, it reflects over the x-axis. If the negative is on the inside, it reflects over the y-axis. This is kind of different. It's not exactly, I mean, because if you think about it, if a parabola reflected over the y-axis, it would be exactly the same anyway. So, reflects over x-axis and right 4. So I went ahead and sketched this so you can see it. I did the parent function in green. You do not have to do that. It's just asking for you to sketch the transformed function. So that's what it should look like. So I sketched the parent function here in green too. This is a square root function. It doesn't have a reflection because there's no negative inside or outside the square root symbol. It moves, the parent function is, I'm going to do that in red. Oh, let's do it in green. Y equals square root of x. The translation or transformation is left 4 and then down 3. So you can see I took the original starting point, went left 4, down 3, and the same, it's just a mirror image, not a mirror image of it, but it's a clone of it, just moved left and down. Number 9a says write an equation given the description or graph. Linear function slope of 3/2. And then y-intercept of -7, so -7. So it's just linear, so it's y equals mx plus b. Quadratic function, vertical dilation of -3, left 6 units, and translated down 6 units. So vertical dilation, so we know we're going to have parentheses and then the x in there and then the exponent. Vertical dilation is our -3. I didn't leave myself enough room. And then what else was it? Left 6, so that's +6. And down 6, and that's -6. So this is an absolute value function. Absolute value functions are really similar to parabola, so similar to the quadratic functions. The vertex starts here. It's a slope of 1 and a slope of -1 on either side. So the vertex moved 1, 2, 3 left, and then down 1, 2, 3, 4, 5. The slope here looks like 1, but it's actually not. It is 4 over 3. So slope 4 over 3. The equation for an absolute value function is y equals, and then you have your a, and then you have this absolute value symbol, x minus h plus k on the outside. Very similar to what we've been doing. So our equation is going to be y equals, and then 4/3 is the slope or the compression or dilation. And then inside the absolute value, x, and then left 3 is going to be plus 3. And the reason for that is because minus -3 minus that left is plus 3. And then on the outside, down 5 is minus 5. So that's the equation for that one. This is a square root function, and it was actually reflected across the x-axis. So I'm going to have a negative out here. Let's see. There's no like change in the there's no like vertical compression or stretch or anything. So it's just a negative on the outside, and then your radical. And the only thing that happened with the original starting point, it was moved left 2. So that's going to be x plus 2. Now, if it had been across the y-axis instead of across the x-axis, this negative would go in here, and it would have been like this, but then this x plus 2, you would put that like in parentheses, because it would end up being negative x minus 2. So this is not the answer, but if it had been across the y-axis, the negative changes everything inside the radical. This, like I said, this is not the answer. This is the answer right here. But just so you know, if it's across the y-axis, it changes both of the terms under the radical. So that's the end of this review packet. You should also expect to see some problems on factoring trinomials, both with a equals 1 and a is greater than 1. Let me know if I can help you in any way, or if you have any questions.